Welcome, kids, to Dr. Ronald Finkel's science experiment. So, Mr. Costal tells me that you're learning about inequalities, and one thing you see here is that I can fit no more than 200 milliliters no more than Mr. Costal, you better take it away. You better take it away.
Okay, Dr. Finkel, thank you. So, boys and girls, let's use his example. He could fit 200 milliliters in his beaker. So, he can't fit any more than that. When he added more than 200 milliliters, everything went over. Well, we had a chemical reaction, but 200 milliliters is the most amount he can fit in that container. So using L for liquid, we have L could definitely equal 200, and he could have that. That's the maximum amount he could have. Now, could he have greater than 200 milliliters? No, that's not possible. If so, then it would go all over the ground like it did. He could have less than 200 though, so he could have 100, 150, even 1 milliliter. Now, we can take these two symbols and we can actually combine them, and we could have liquid is less than or equal to 200. All right, and this is how we would represent the inequality of liquid that he could fit in his beaker. Now, when we graph this, we're going to go to 200, put a circle. Now, we have two options to keep that circle open or close it. If we see this equal sign here, then we're going to close that circle. And we're going to highlight everything less than 200 because that's how much you can fit. Okay, so now we're looking, how can we solve an inequality using addition or subtraction? And boys and girls, this is great because this is just like we did with algebra tiles in class. All right, we're trying to make changes to each side so that we can get x by itself. All right, so our goal is this. Now, the greater than symbol comes just down, just like our equal sign when we worked on the computers and when we were actually using the algebra tiles. Now, how do we get rid of a negative 3? We can add 3. And I've said this a million times, if you change something to one side, you have to change it to the other. So we add 3 over here, and we get 4. Now, our answer, x isn't equal to 4, because if we plug in 4 minus 3, we get equal to 1. So 4 isn't a possibility. Now, this is important for our graph. The reason it's important for our graph is because when we graph this, if it's not equal to, we're going to keep an open circle. We're not going to shade it in like Dr. Finkel's example. X is greater than that. So we could have x equaling 5. And let's see if that would be true. Well, 5 minus 3 is 2. Is 2 greater than 1? It is, so that works out. Could it be 6? Well, 6 minus 3 is 3. That is greater than 1, so that works. So we would shade everything above 4 with keeping that circle open.